Hello again, everybody. Just picking up from where we left last time because my video time expired. We figured out last time that in this picture, this bottom angle here was 46 degrees. We realized that this angle up here, up the top, was 88 degrees because of the angle sum of a triangle. And what that meant was that these two angles here, they actually form this Z shape. Okay, they form a Z. And because they form a Z, they're alternate angles. So we're actually using the converse to prove here. So you're going to write as your final statement that we ran out of time for is, since angle CBD equals angle BDE, and they both equal to 88 degrees, you're going to write alternate angles exist and are equal. Therefore, AB is parallel to ED. Okay, do make sure that you write down your summary of that section and that you also write down all the notes for this section and have a go at the homework depending on what level you choose. Okay, so this lesson is going to be looking at congruence triangles and just revising some of the tests and proofs for that. Okay, so you need to be able to apply the meaning of congruence triangles and tests. And this is looked at in exercise 4.4. So the first little bit here, all this stuff is just kind of reminding you about angles and sides in triangles. Now the course kind of has changed recently, so it's important that you know that corresponding just means matching. So can you actually cross that out and write matching in there? Because they don't really use corresponding unless they're parallel anymore. So just cross all these out and just write matching there instead. Okay, that's really important. So same with here, these should all say matching. Fantastic. Alrighty, so moving on, there are 4 tests for congruence that you should have learned in year 9 and 10. So they're listed here: SSS, SAS, AAS, and RHS. Okay, so SSS just means you've got 3 sides of the first triangle equal to 3 sides of the second in the same order. SAS is a really important one. You have 2 sides equal in both, and the included angle means the one in between the 2 sides. And that's really important to know. So if you've got 2 triangles, then the included angle in this case would be that one there in between the 2 sides. Okay. Then we've got AAS. So AAS is really looking at 2 angles and one side of a triangle equal to the other in both, and then right angle, hypotenuse, and side. So 2 sets of hypotenuse, a side in the same position, and a right angle in both are equal. Okay, so that's kind of really important. All right, let's quickly go through some of these examples together. The first one gives you a picture, and it says ABCD is a quadrilateral in which AB is parallel to DC. That's labeled here with the little arrows. And AB equals DC, that's labeled with the markings. It says prove that triangle ABD is congruent to. So remember this symbol here, that means is congruent to. This symbol means parallel to. Okay, so if you didn't know that, you need to write that down. So the 3 horizontals is congruent to, and the 2 verticals is parallel to. So we always start off any congruence proof the same way. We start by going in triangle, whatever your triangles are. So in this one, it's ABD and triangle CDB, comma. So you always start that way in a congruence or similarity proof. And then what we're going to do is look for some of the things we've been given. We've been given that AB is equal to CD, and that's actually given. So I'm going to write that down. You could write DC as well. The order doesn't matter because that's given up there. The second thing we can write is that angle ABD is actually equal to angle BDC. So which ones am I talking about? This one here is equal to this one here. My reason, alternate angles on parallel lines are equal. And you should really say which parallel lines you're using. So we're given AB is parallel to CD. And then I'm going to say that BD, so the line in the middle, is common. In other words, it's a shared side. Okay, and then because of those three things, I can say that the two triangles are congruent. And I need to write which test I used. Okay, so I used a side, an included angle, and a side. So SAS test. It says show that AD equals BC. Well, because I've just proved they're congruent, we write the classic reason, which is AD is equal to BC, and my reason is matching sides of congruent triangles are equal. Okay, the next section asks me to prove that AD is parallel to BC, and we're going to do this by using the converse. Okay, we're going to do this by using the converse. So for part C, I'm basically going to say angle ADB equals angle CBD, and they are matching equal alternate angles in congruent triangles. So because the fact that they're congruent, you can say they're matching equal alternate angles, and because they're alternate, therefore AD is parallel to BC. Okay, so that's the first question done. So all of these questions kind of follow this pattern. So make sure you write down the notes and write down any questions in the question section if you have some to ask me, so you can ask me later. Okay, moving on quickly. Question 2, find the pronumeral in each picture. So the first thing you want to think about is a congruence proof in this one. Okay, so I can see I've got a right angle in both, I've got a side given, and the hypotenuse are also given. So I'm going to prove these two triangles are congruent. So I'm going to go in triangle AEB and triangle DEC. I'm going to list the things off. So I'm going to go AB is equal to CD, and that's given. Then I'm going to go AE is equal to EC, and that's also given. And I'm going to write that angle B is equal to angle D, which equals 90 degrees. And that's actually given in the diagram too. So given is anything that's given in the picture. And I'm then going to say that the two triangles, AEB and DEC, are congruent because of the rule RHS. Because I use the right angle hypotenuse side. Cool. So because they're congruent, I can just say straight out, therefore x equals 56 and D is equal to 11.5 centimeters. And my reasons for those are the classic reason, either matching angles in congruent triangles, are equal or matching sides in congruent triangles are equal. Okay, so you can write the rest. Fantastic. Okay, moving along, and this section of work may go over 2 videos as well. We'll see how we go. The next bit says that PR is the bisector of angle QPS and QRS. So it's basically showing that these 2 angles are equal here, and these 2 angles are equal here. Okay, your job is to prove that those 2 angles are equal. So I'll talk you through it and then you guys can have a go at this one. But basically you need to prove the triangles are congruent. Okay, prove they're congruent, step 1. And then step 2, you need to say that therefore these 2 angles are equal because they're matching angles in congruent triangles. So I want you guys to have a go at that one by yourself. Okay, question 4. This one's a bit more tricky. It says in equilateral triangle ABC. So first up, I know these sides are all equal. It says AD is the bisector of angle BOC, so those are equal angles, the 2 dots, and AD meets BC at D. My job is to prove that AD is perpendicular to BC. So the first thing I'm actually going to do is I'm going to prove that these 2 triangles are congruent. Surprise, surprise. So in triangle ABD and triangle ADC, I'm going to say angle BAD, angle BAD, equals angle CAD. Okay, angle BAD equals angle CAD. And now I'm going to say that's because they're actually given in the picture with the dots. Okay. Then I'm going to say that AD is common because it's a shared side, or you can write AD is shared, but this line down the middle here is shared. Then I'm going to say the final angle B equals angle C. Why? Well, they equal 60 degrees because they're equal angles in equilateral triangles. Fantastic. So that then gives me my proof. So therefore, they are in fact congruent. So triangle ABD is congruent to triangle ADC. And my rule that I used was actually AAS. So I've got to write that down. Cool. So basically what that means about these 2 angles here is they're equal because they're matching angles in congruent triangles. So I'm going to write that down. Angle ADB equals angle ADC. And you're going to write your reason, matching angles in congruent triangles are equal, but because they're equal and they're on a straight line that make 180, that means they're equal to 90 degrees. So therefore, angle BDA equals angle CDA equals 90 degrees. And I'm going to write adjacent supplementary angles. You guys write that in. Don't abbreviate like that. I'm just running out of time. And I'm going to say that, coming up here, I'm going to say, therefore, AD is perpendicular to BC. So that symbol there, this symbol means perpendicular to. Fantastic. The last little bit, which I'm probably going to run out of time for now, so I'll talk you through what to do and you guys can have a go at it, is you need to prove that triangle BOP and AOP are congruent, and then basically BP will be equal to AP because of matching sides in congruent triangles. Write your summary, have a go at the exercise,